Welcome back. It's time to talk about some double angle formulas. So you should have your sheet handy just in case you need them. And we're going to show you how to do one double angle identity proof. We're going to do 2 questions and then we're done. So first thing we're going to do is we're going to prove that sine of 2x is equal to 2 times the sine of x cosine of x. To do that, we're just going to split the first part into sine of x plus x. And now, of course, that means we're going to use the sum of sines formula, which is sine x times the cosine of x plus the cosine of x times the sine of x. And that's still equal to 2 sine x cosine x. And of course, 2 times 3 is the same as 3 times 2, so sine x times cosine x is the same as cosine x times sine x, so there you have it. 2 sine x cosine x is equal to 2 sine x cosine x. Done. So there's a little identity proof for you. So now let's get to the fun stuff, using those formulas. So we're going to find sine of 2a, cosine of 2a, and tangent of 2a. Of a certain angle ratio and a given quadrant. So the first thing we need to do is, of course, draw angle A in quadrant 2 that has an 11/61 ratio. So sine is opposite over the hypotenuse. And now what you're going to need to do is a little Pythagorean theorem magic and do 11 squared plus b squared is equal to 61 squared, and you're going to get 60. However, since we are in quadrant 2, that's when our x values are negative, so make sure that you have a negative 60 there. So what are we going to do next? Well, we need the cosine of a and the tangent of a because we already have the sine of a. So we know that cosine is adjacent over hypotenuse, so the cosine of A is equal to negative 60 over 61. And the tangent of A is equal to the opposite over adjacent, so it is 11 over a negative 60. So what are we going to do from here? We're going to just use the formulas on your sheet. So we start with sine of A is equal to, 2a. And that's going to be equal to 2 times the sine of A times the cosine of A, which is going to give us 2 times 11 over 61 times negative 60 over 61. And that's going to give us, use your calculator, exact answers only please, negative 1,320 over 3,721. And you're done. So now we have to go find the cosine of 2a. So the cosine of 2a, you have, use any one of the formulas. So it doesn't matter which one you want to pick. So I'm going to use the 1 minus 2 sine squared a. And that's just as easy as typing in your calculator again. 1 minus 2. And then we know that the sine of a is 11 over 61. So that's 11 over 61 squared. Type that in your calculator, change it to a fraction, and you get 3,479 all over 3,721. And then the last step is to find the tangent of 2a. The tangent of 2a could be done with a formula, or you can just use your good old-fashioned identities that tangent is sine over cosine. So you can just do sine of 2a over the cosine of 2a. So we know that fractions, dividing fractions, are the same as multiplying by the reciprocal. So that's just going to be negative 1,320 over 3,721 times 3,721 over 3,479. And of course, that's just going to simplify. And once we simplify, that's going to give us negative 1,320 over 3,479. And that's it. You are done with this example. So it's just that simple. All you have to do is substitute all these values into your calculator and find the fraction value, and you're good to go. So why don't you try number 3 on your own? Draw the triangle where it belongs, find all of your side lengths, and just use SOHCAHTOA to figure the rest out. Pause the video, try it on your own, and when you're ready, just press play. And there you have it. You should have sine of 2a is equal to 24 over 25. The cosine of 2a should be negative 7 over 25, and I did it using the other formula. Really, it's up to you. And finally, tangent, I also used the tangent formula just to show you that it still will work out. Or remember, it's just sine times the reciprocal of cosine. The 25s will cancel. You still get negative 24 over 7. Just wanted to show you that it works. All right, this is Longo, and I'm out. See you, bye.